Today we're going to look at alternating current. Specifically, we're going to be answering question on the RLC series circuit. And RLC represents the resistor, inductor, and capacitor. So we are talking about resistor, inductor, and capacitor series circuit. We have a question here. A capacitor of capacitance C is 6.37 microcoulomb. Inductor with inductance, this is the inductance, L equal 2,547 millihenry. And resistor with R equal 400 ohms are connected in series with a sinusoidal voltage source of peak value 250 volts and frequency 50 hertz. Compute I1 says the root mean square voltage across the source. I2 the impedance Z, I3 the power factor, I4 that is IV the peak value voltage across each element. 5 the frequency at which resonance occurs. 6 here the average power dissipated in a circuit at resonance. And lastly, we're going to calculate the average power in the circuit. Let's look at the first solution. Solution 1, I1. We are finding the root mean square voltage across the source. We use this formula. VRMS equal V log over the root of 2. So we have the root of 2. Now, here, we're going to substitute the value. For the root mean square voltage, we're going to find and substitute the value for the peak value voltage. So VRMS equal 250 V all over the root of 2. We put this in our calculator and then divide by the square root of 2. Of course, the root mean square voltage is 177 volts. Part 2 of the question says we should calculate the impedance. The impedance Z equal the square root of R squared plus X squared. Now, this R represents the resistance. The X squared represents the difference between the inductive reactance and the capacitive reactance. Now, the question did not give us these two reactances, so we have to find them. Say X equal X of L minus X of C. For X sub L, that is the inductive reactance, is equal to omega times L, the inductance. But omega is equal to 2 pi the frequency. So if we substitute 2 pi F for omega multiplied by the inductance, then our new equation will be the inductive reactance will be equal to 2 pi F L. Then we're going to substitute in the values so that we can get the solution for the inductive reactance. If we do that, we multiply, we have 2 pi, we're going to use 3.14 for pi. The frequency, of course, is 50 hertz, and then the inductance is 2,547. Now we converted from millihenry to henry. So it will be 2,547 times 10 to the power negative 3. We multiply that, we're going to get 800 ohms. Then we find the capacitive reactance. The capacitive reactance is equal to 1 over omega multiplied by the capacitance. Remember, omega is equal to 2 pi F, that is 2 times pi times the frequency. So we have 1 all over 2, pi value is 3.14, the frequency and the capacitance. At first we have the capacitance in microcoulomb. We have to convert it to coulomb. That is a factor of 6 here. Now we multiply and we divide this value, we get 500 ohm for the capacitive reactance. Now we go back to our formula. We say X equal XL minus XC. We have to find the difference for this X here so that we can find the impedance. Now, XL is 800 ohms, and then XC, which is the capacitive reactance, is 500 ohms. When we find the difference between the two, we get our X equal 300 ohms. Therefore, Z, that is the impedance, will be equal to R squared plus X squared. Remember, we already got the value for X squared. That is, we form our inductive reactance and our capacitive reactance. We find the difference. Now we are going to find the impedance. Now for the resistance is 400 ohms. We're going to square it plus the X difference between the inductive reactance and the capacitive reactance is 300, and we're going to square that, of course. If we square 400, we get 160,000 plus we square 300, it gives us 90,000. We add all two together, then put it under the square root, and we add it, we got 250,000. Now, the square root of 250,000 is 500. That's how you know here is ohm. Now, we look at solution 3, so we should find the power factor. The power factor is cos phi. It's a Greek letter, right? It's pronounced something phi, phi, whatever, okay? So, cos phi equal R, which is the resistance or the impedance. Now, the resistance is 400, and then the impedance is 500. Just divide that. Our power factor will be 0.8. The power factor does not have SI unit. Now, come to IV. IV said we should find the peak voltage across each of these components, across the resistor, the inductor, and the capacitor. So we look at the peak voltage across the resistor. But before that, we have to find the current. It's Ohm's law. You see Ohm's law. Because the voltage, right, is equal to current and the resistance here. So we have to use Ohm's law. Now to find the current, the peak value current will be equal to the peak value voltage divided by the impedance. Now for the peak value voltage, we have 250 volts, and of course the impedance is 500. Divide that, give us 0.5 amp. So this is the current. Using Ohm's law, V naught time R will be equal to R naught R. That is the voltage across the resistor. So for the current is 5 amp, the resistor or the resistance is 400 ohms. We multiply 0.5 by 4 ohms. 400 ohms will get 200 volts. RVB, that is the voltage across the inductor. Using Ohm's law again, right? We have the voltage across the inductor because of the current multiplied by the inductive reactance. Now, the voltage across the inductor because the current is the same, right? The same current pass through the three components because they are in series. Okay, 0.5 amp multiplied by 800. Of course, we are taking half. So our answer is 4.00 volts. So that is it. Let's look at the next one. Solution 1RV, letter C. We are finding the voltage across the capacitor. Voltage across the capacitor is equal to the current, the peak value current, multiplied by the capacitive reactance. The current that flows through the three components is 0.5 amps, so the same current flows through them. 0.5 amps and 500 give us 250 volts. Now we go to solution 1. V. So you find the frequency at which resonance occur. Resonance occur when the inductive reactance is equal to the capacitive reactance. At that point, we say resonance has occurred. Okay, now I'm going to use angular velocity here, omega naught, equal to 1 over the square root of the inductance multiplied by the capacitance. When we plug in the value here, because the angular velocity SI unit is radian per second, so it's rad per second. So we're going to take a factor of 10 here and divide this here by the square root of 22, multiply by the radian, the SI unit. Our value will be 248 radians per second. Now, because the resonance frequency is equal to omega naught or 2 pi, is why we have to find this angular velocity to find the resonance frequency. So, angular velocity is 248 radians per second, or what? 2 pi is 3.14. If we divide this value, we get 39.5 Hz. That is the resonance frequency. This is the resonant frequency. We got the solution 1 RV or VR6. Now, the average power, right? The average power is equal to the root mean square current multiplied by the root mean square voltage times the power factor. But at resonance, the power factor is equal to 1. At resonance, the power factor is equal to 1. Let's remember that. So if the power factor is 1 and we multiply by this value, we just get the root mean square current times the root mean square voltage. But the root mean square current is equal to R naught over the root of 2. So, in the place of R and S, we put R naught over the root of 2 right here. The same thing to the root mean square voltage. VR and S equal V naught over the root of 2. So in the place of the root mean square voltage, we insert V naught over the root of 2. Then we plug in their values. The current is the same, so it's 0.5 root of 2. The peak voltage is 250 volts over the root of 2. We put 0.5 over the root of 2, multiply by 250 over the root of 2, we get 62.5 watts. That is the average power factor at the point where in resonance occur. So we're going to look at the next one shortly. Lastly, we're going to look at solution 1 VRR. Says we should find the average power in a circuit. The average power is equal to the square of the root mean square current multiplied by the resistance. So like I told you initially, that RMS is equal to the peak value current over the root of 2. So we insert that here, and we have R, we're going to square that. The current is 0.5 over the root of 2. The resistance is 400. So if we square this part, we get 0.125. And multiply this by 400, answer to the question is 50 watts. This is our answer. Thank you so much for watching. Please subscribe, share this video, follow my page on YouTube, follow my page on TikTok and Facebook. Thank you so much.